Let's say you want to add two vectors. We'll have the vector A plus the vector B. So graphically, the way you do that is you draw your vector A, but when you go to draw B, you maintain this orientation, but you start drawing it at the tip or the head of A. So if I do that, it's going to look something like this. And then to get the resultant, or the sum of these two, you go from where I started. So I'm starting right here. I would go from here to where I ended. This is what we call the resultant, and it equals A plus B. So it's good to know about this because visually we can see what's going on. But in terms of getting the answer, it's not the best way. A better way to do it is to break these vectors into components. And if we do that, then what we see is that what we're adding is the x components and the y components. So what you do is if I'm taking A plus B to get this resultant, what I need to recognize is that means I'm doing A sub x plus B sub x, and that's going to equal the x component of the resultant, so the x component of this vector here. And then I do the same, but only with the y components. And if you're not sure how to get these components, you should watch the other video that shows how to get the components of a vector. So I'm adding two vectors together. I need their components, and I add the like components. So here I combine the x components, and here I combine the y components. And that gets me the x and y components of the resultant. Then, to get the magnitude of the resultant, we just use Pythagorean theorem. So now I just do rx squared plus ry squared. That's going to equal r squared. Right? So take the square root, and I'm done. If I want to get the angle, this resultant is just a vector, and like any other vector, I can draw it as the hypotenuse of a right triangle. So if I want to get the angle, for example, with respect to the horizontal, and this is covered in the previous video, but I just take the arctangent of ry over rx. That'll give me the angle with respect to the horizontal, the angle theta. If I want the angle with respect to the vertical, then I'm doing rx over ry. And that's all there is to adding two vectors. If you want to subtract two vectors, the only thing that changes is, for example, if I was doing A minus B, then what changes is instead of putting a plus here, I put a minus. And I just do that here and here. That's all that changes in terms of this math. Everything else in terms of the math here stays the same. The difference would be, so let me just draw this, if I was doing A minus B, so if I was doing A minus B, that's the same as A plus negative B. So I would have A plus, and I would take negative B. Negative B would point the exact opposite direction. The exact opposite of what it was previously. And then I just follow the rules for addition here. And so that's why I say if you go through, well, let me finish drawing this first. So this would be like this. That would be A. B would look something like this. The negative B, I should say. That's negative B. That's A. And this this resultant is A minus B. That's what this resultant is. And the only thing that would change in all of this work here is here with the components, instead of doing ax plus bx, I would be doing ax minus bx. And here would be ay minus by. That's the only thing. I guess here this would say a minus b. But that's all that changes. This stays the same, and these would stay the same. And again, this theta is the angle with respect to the horizontal. This is angle phi is with respect to the vertical.